In this video we're going to find the partial derivative of w with respect to u. So the first thing is to try and understand what's going on. So here we've got w expressed explicitly in terms of x, y and z. So what that means is this: you've got a some sort of machine where you input x, y and z, and then it will spit out some sort of value w here, w. So so in your mind picture the 3D scenario where this is x, this is y, this is z. You've got some sort of surface. Let's just say, I don't know, let's just imagine it to be some sort of surface, and at any given point, let's say 1 across, 2 in the y direction, 3 up, at this point here it will spit out a value w. So imagine w, imagine this is w here, 0, 1, 2, -1, -2 and so on. So let's say at this point it spits out the number -2. So you want to know the partial derivative of w with respect to u. Well, if you look at this thing here, x is driven by u and v. So if you look at this, everything is driven in terms of u, v, u, and then u, v. So the point here is that you've got your u here and you've got your v, and from these two variables will determine where the particle should be in the x direction, in the y direction and in the z direction. So you always know where the particle will be from these two variables. So we want to know partial derivative of w with respect to u at this location, -2. So this would be -2 and this would be 0. This would be 0. So we want to know partial derivative of w with respect to u. So it's going to be partial. Okay, so let's proceed. So from here, using the chain rule, consider in the x direction, consider the y direction, consider the z direction, and I'm expecting you to know this by now. So so now take the partial derivative of w with respect to x. So this thing here would be you looking at this and imagining that this is a bubble. So when you come to differentiate, when you take the partial derivative with respect to x, this is going to be a constant. Y would be a constant, z would be a constant. So that would be 1 over the bubble itself, which would be x squared plus y squared plus z squared. But then you've got to times the derivative of the bubble itself. Remember that this is a variable, this is a constant, this is a constant. So this would be 2x, and then it gets multiplied to the top, giving you this thing here. So this bit here will give you this. Now we've got to times it by the partial derivative of x with respect to u. So we've got to look at this thing here. Partial derivative with respect to u. So that would be looking at this. U would be a variable. So you've got two blocks here. So this block here contains u. This block here also contains u. So these two blocks, these two blocks contain a variable u. So therefore we've got to use a product rule. So the product rule would be differentiate the first, leave the second alone. So when you differentiate this, remember u is a variable and v is a constant. So when you differentiate this, it would just be this thing here, and then leave the second alone. That would be this. And then the second part of the product rule is you leave the first alone and then differentiate the second. So you leave the first alone, and then differentiate the second. That will then give you this. So that's this part taken care of. That gives us this whole thing here. Now look at with respect to y. So with respect to y, it would be, hang on. It will be looking at this. So we are now trying to do this part here. With respect to y, that would be hang on. that would be 1 over the bubble, and the bubble happens to be x squared plus y squared plus z squared, and then times the derivative of the bubble itself. Well, this is a constant, this is a constant, this is the only variable here, so that would be times 2y, and then this gets multiplied to the top, giving you this. Now find the partial derivative of y with respect to u. So for this part here, go back to here, and then take the partial derivative of y with respect to u. So so that would be, well, hang on, this will be a variable, this will be a variable, so therefore we've got to use the product rule again. The product rule is differentiate the first, leave the second alone. That will then give you this thing, and then leave the first alone, differentiate the second. That will then give you this. And now now we've got to look at this thing here. So now partial derivative of w with respect to z. So going back to here, partial derivative with respect to z. So that would be 1 over the bubble intact, and then you've got to times the derivative of the bubble itself, which will be 2z, which is 2z. So that would then give us this thing here would then give us, hang on, let me think, 2z. Oh yeah, that would then give us this thing here. That would then give us this thing here. 2z over that thing. 2z over that thing there. So that would give us this thing here. Now we've got to look at this part. So this part, we would go back to here. We would go back to here, and then take the partial derivative of z with respect to u. So u is a variable, v is a constant. So when you differentiate this, it would just be e to the power of v. So that would just be e to the power of v. Well, anyway, this whole thing here will then give you this thing here. But now we want the answer all in terms of u and v. So let's just look at these three: x squared plus y squared plus z squared. So let's look at these. So so a side note, this thing here becomes very simple. These bubbles here become something really simple, really clean. So hang on. So side note, x squared plus y squared plus z squared. Remember, these were given to us right from the start. So when you square this, so you've got one block multiplying with this block multiplying with this block. When you square it, it would be hang on, you multiplying it by its exact same self. So that would be this. That would be u squared, and then that would be e to the power 2v, and then that would be sine squared. So that would then give you this. And when it comes to y squared, well, y squared would then give you this thing here, and then z squared would then give you this thing here. And then notice that these are in common, so you can factor out u squared e to the power 2v. That will then give you this, and then this block here is just a number 1, so that becomes 2. This thing here will become 2. So this whole thing here becomes this, and then you can simplify it even further, because when you put this into the u and this into the v, so v would be the number 1. Well, this whole block would be the number 1, and then put this into here. Negative 2 squared would be 4. 4 times 2 would be 8. So overall it equals 8. So we know that this, going back to here, this block here, this bubble here, is the number 8, and this bubble here will also be the number 8, and this will be the number 8. So this whole thing here would then become this thing here, and then you've got y over 4 and z over 4. I hope you can follow that. So for the time being, well, you've got, remember this thing here is 8, so that would become 1 over 4. So you've got x over 4 here, and then you've got this weird block, so x over 4 and that weird block. So you've got x over 4 and that weird block, and so on, and then you've got y over 4 and that weird block, and this thing here. So now we are currently here. So now now we've got to put, hang on, so we are currently here, and now let me think. Now if we put negative 2 into the u and 0 into the v and negative 2 into the u, this x here would then become this. So this thing here would then become this, and then do the same. This thing here would then become this, and this thing here would then become this, and so on. This whole thing here would then become this thing here. Okay, think about it. Press pause and maybe have a look. So now now what? Let me think. This block here, sine is an odd function. Sine is an odd function. Remember, an odd functions, when you have sine of negative 2, that's the same as negative sine, the positive version. So so we can replace this with this thing. Well, you got a negative here. So anyway, tidy this up. That will then give you this. Sine is an odd function, so that becomes the negative version of the positive version, if that makes sense. And sine and cos is an even function. Remember, an even function is when it's symmetrical along the y-axis. So cos negative 2 is really the same as cos of the positive version. So this thing here will become the positive version, and this thing here will become the positive version. This thing here will become the positive version. This thing here will become negative the positive version, if that makes sense. Anyway, tidy up, it will then give you this, and then blah blah blah, the answer will be negative 5 over 2. That's your final answer. Okay.